Hi, everybody. I'm psyched to be here. I'm psyched to talk about this. So let's see. I'm Adam Wolff, and today I'm going to talk about rebuilding Facebook chat. And actually, there was a big project going on to rebuild all of Facebook chat, including the back end. But I'm going to focus on the front end and the JavaScript we wrote. It seems appropriate. And you may wonder why we felt like we needed to rebuild Facebook chat. And the answer was that it was pretty terrible. And I pulled something that I remembered from about a year ago. This was like a blog post announcing our new subscribe feature, so you could follow people on Facebook. And the very first comment, it was posted a minute after this went up, says, "Improve the chat system." And there are 1,000 likes on that comment. So, and actually, this was a problem for us because the complaints about chat just drowned out our overall user feedback. It was like really hard to tell when we had new bugs and stuff, because people were always complaining about chat. And Facebook chats, I think it's somewhat unique as a client-side application because it's embedded in this browse experience. Facebook is still delivered very much as like a page-to-page classic web application. So we can't afford to load a bunch of code and then go back to the server to build up a bunch of state, because we're going to get paged out quickly. The other thing is that the scale of Facebook chat is enormous. It's at our peak, it's hundreds of millions of concurrent users. So every extra fetch to the back end means extra latency and extra servers, more cost for us and a worse experience. So I think it's kind of funny. We've been doing JavaScript and web apps for a while now, and it's still not obvious how you build a feature like this. Everyone builds their own language and their own servers for this and everything. So we kind of approached this not sure of what we were going to do to fix this. Before we go into what we did, I want to show a little bit about what Facebook chat does. Do people here use Facebook chat on the web? Some people do. I figure this is more of a Twitter crowd, but no worries. I'll show you what it does. OK, so here I have my alter ego, Tabiko Jones, his Facebook page. And I'm going to start a chat with Nan, one of the Facebook contingent who's here. And the very first thing I want to show is that one thing that we did is, oh, thanks, Nan. One thing that we did is, let's try that again. When we merged chat and messages, we used to have two different products. There was this jewel at the top. We call this thing up here the messages jewel. And then we also had chat windows. And we merged the backend for these things because we felt like, hey, you're talking to your friend, in either interface. They should be the same thing. But we didn't merge the front end of these applications. So the jewel was controlled by one set of client code, and the chat window was controlled by another. And they would get out of sync all the time. That was actually the dominant form of angry feedback. So Nan, will you send me another message? So now you'll see that when Nan sends me another, thanks, Nan. When Nan sends me another message, you see they appear in both interfaces at the same time. And so fundamentally, this was what we had to do. We had to introduce a model for what chat was doing and make it more than just a very simple app. It used to be just something that was all about the UI. A couple other features I want to show here. Let me minimize this window, and maybe Nan will send me one more message. I think he's out of prepared comments, so hopefully he has to type something on his phone. We'll wait for that to come in. OK, there we go. So now I have a new message, and I'm going to actually reload the page here before I do. And what you'll see now is what I wanted to point out about this is that even though people have messages when they come to Facebook, chat is not the most important feature on Facebook. Obviously, it's the news feed. So half of our users don't engage with chat at all on a given day. So we can't afford to load all the messages when the page comes up. And what that means is that now when I raise this chat window, you'll see a little tiny delay where we have to go fetch the conversation before we can show it. And even though we've done that, we still haven't loaded all the data for the model. When we go look at our list of conversations, you'll see that has to get loaded in as well. So we very much have to emphasize incremental loading. They did take away my shaving cream. Yes, that's right, Nan. OK, oh, and I'm getting lots of messages here. Hi, everybody. One last thing I want to show is that there's a group chat feature here. And this makes this much more complicated. So Tabiko here is going to add Adam to this chat. And this is a new group chat. And maybe Nan can add some people too. And the thing I want to point out about this is that Nan can add people who are his friends to this chat. And these are people that Tabiko doesn't know. So he doesn't have information about these participants, and those need to be loaded incrementally, sort of as these messages come in sort of real time. Oops, I lost focus. There we go. So that's actually something that we had to contend with, and I'm going to show a little bit of code that kind of gives an example of how we dealt with that. OK, so back to presentation. So we did this rewrite, and I think we can say it was a success. One thing that we really got to do was we really got to focus on the technology and the quality. We didn't have a bunch of new features to add. It was pretty minor in that regard, so that was very helpful. We developed a new command line JavaScript test framework as part of this project, and it's been adopted across Facebook, and now we're working to open source it. So I'll talk a little bit more about that. The whole project took 6 months. Most of the time, it was just 4 engineers working on it. It wasn't like a gigantic project. And what I'm showing here is the graph of user tickets. Now, unfortunately, at Facebook, each individual user report surfaces to us as thousands of users complaining about things every day. But we can tell we're doing better when those thousands become hundreds. And that's kind of what happened here. And it's gotten better since. So you can see that this was really helped with the quality. There are other things we're doing too. The very first thing that I want to talk about, and the most important thing, and the thing that I would sort of suggest you remember from this talk, if you're going to remember one thing, is that we introduced modularity into the Facebook JavaScript code base in order to deliver this feature. And that was the single best thing we did, because even if you have a big steaming pile, if you have a steaming pile that's in little buckets, then you can fix them one at a time. That's the single best thing that we did. So when I joined Facebook, a little over 2 years ago, all of our JavaScript was effectively in a global namespace. You just write var blah equals blah, and that would just kind of run whenever it ran. You could give directives that say, hey, when you load this file, you also need to load these other files. But there's no guarantee about what order that would happen. So it made it really, really complicated. And any JavaScript code could break any other JavaScript code. So it's really easy to cause a problem, and then really hard to figure out who had done what. And the other thing was that we have this stochastic packager that actually takes data from production and tries to do the most efficient job it can, putting JavaScript files together. So the packager would change what JavaScript was delivered in what bundle, and that would cause bugs even though no code had changed. That makes it really hard to figure out what's going on. And the last thing that this leads to is just layers and layers of initialization, because you kind of it's really hard to know when everything's ready. Everything sends an init event, and you end up depending on 20 init events before you are ready to do anything. So we fix that with CommonJS effectively. So now at Facebook, when you write a file, you can require resources, and then you just can export something. This gets transformed into something like a define function along the lines of require.js. We didn't actually pull in require.js because it's kind of easier at Facebook to just do it over, unfortunately, often. But we're definitely inspired by require.js. So you can see that now, the contents of a given file get run inside a function. You get global namespace protection, all kinds of good stuff, and you get this initialization guarantee. There's only one module named foo, and you kind of know when it's ready. Now, ideally that would have been enough, but for our application it wasn't. And the problem that we had was that most dependency chains in our app actually start on the server. So if you think about I'm going to talk about that chat tab window that appears at the bottom of the screen, and just imagine the control that renders that, right? So in addition to all the data it needs a couple other things, like a configuration from the server, and also the templates we actually deliver from the server as well. And you may wonder, like, why in a client-side app we're delivering templates from the server. The best answer is that internationalization is really, really hard. And we have a big legacy stack for doing that on the server. So we internationalize a template on the server and then deliver it to the client. There are other things that we do with these templates that are also helpful. But then you're back to this multi-pass initialization thing where you have a module called chat tab view, but you can't use it right away. Requiring it is not enough. And instead, and the other thing that you have is like when you want to deliver these resources to the client, you have this like gross interconnect between PHP and JavaScript, where PHP in our case, sorry, where you have to like require this module and call a method on it. And this is a really hard dependency to track. Like it's effectively a string in PHP. So if you want to refactor that method, it's a pain. Also, if you want to share this config, you end up doing this like 50 times. So the way we fix this is we introduce this idea of dynamic dependencies, where you can define modules on the server. So you just sort of export like a bunch of configuration as a dictionary or a template as even just like a string, and then you can require these templates. Now, we don't use the require keyword, even though to the client these things look the same as regular modules. We use require dynamic because the one thing about this approach is that it is a little bit fragile, right? Like you can end up with a client in a state where it needs a module that the server forgot to prepare for it. So by using require dynamic, we can kind of keep better track of what the client needs in order to be able to initialize. But you can freely mix require dynamic statements with regular require statements and then go about your business. So this worked really well. And as I said, like if there's one thing that made this project work, it was the fact that we could put our chat code, our new shiny chat code, in modules that would not be broken by the rest of the JavaScript at Facebook. There's a couple things I feel like we didn't quite get right. So if you go down this road, there are things I would do differently. The very first thing I would say is I really wish we hadn't allowed circular dependencies. I know that's part of the CommonJS spec, and I'd be fine allowing it for third-party code, but in our code, it leads to all kinds of problems. It's really hard to reason about these circular dependencies, and it's really hard to know when you're looking at one module that it's part of a circular dependency chain. The other thing about it is that any time you have something that can execute in arbitrary order, you almost always end up with bugs when that order switches for whatever reason. The other thing I wish we'd done, while we were at it, I wish we had modularized JavaScript code's access to the window and the document in that window. Because just being able to freely refer to the window as a global basically means that you can only have one window in your context. And I think the destiny of all JavaScript code is to run on the server. And when you move this code to the server, you have to contextify it. You have to say there's one VM sort of per request. And then the last thing was just dumb. Instead of doing straight CommonJS where you can give file names, we did this thing where you kind of name your file using a comment. And that was just it's unnecessary garbage now in the system. But overall, big success. OK. The other side of modularity, I think, is unit testing. And I'm presenting these things as if they're different, but I see them as very much the same. You can build a module system, but you don't know you actually have modules unless you have an expression for the seams between these modules. And that's what I see as unit testing being about. So, I feel like a lot of people feel like, OK, I know we need to do unit testing. I know that really helps, especially in an environment like Facebook where you have hundreds of engineers committing to the same code base. But I think one thing that people don't talk about too much is just the workflow benefit of unit testing. I think most developers, I certainly would rather interact with my console and my keyboard than with the browser and the mouse. But in order to make that really work, you need to make the unit testing really fast. So when we had some unit testing for JavaScript, but it was actually slower to run the unit test than it was to reload the web page and click on things. So that's the wrong set of rewards there. The other benefit of unit testing is this design benefit. So, if you have a unit test, you're forced to consider what is this unit? What are the guarantees that it provides, and what are the invariants? So, in order to really capture that design benefit, you need to set up your unit test system so that it, by default, it isolates modules. You're sort of encouraged to test one thing at a time. And then the last thing, and I think this is like really common understanding of what unit testing is for, is the idea that like it's a signpost. You know, if you come back or someone else comes back and wants to change something, like there's a big long list of like, well, this is what it does now. You know, and if you're going to change it, you need to like think about the current spec. But in order to make that read well as a specification, you need to make sure your unit test framework is really expressive. And to this end, I think you need to make your unit test framework hackable. You know, you need to make it so that like developers on the team think of committing to the unit test framework and the unit tests as like just as important as committing to the production code. And you know, like hacking on the unit test stuff is fun because like, you know, if you break it, that's really good. And it's also like it's much more abstract. You know, it only runs in your dev environment. One thing unit testing I think is not for is like as a wall. You know, and so people new to unit testing sort of say like, well, I can write this unit test, but that doesn't prevent you from like, you know, writing some other module that mocks this interface and does the wrong thing with it. And yeah, you know, absolutely. And you can write integration tests if you're really worried about that. But you know, unit testing is about other thoughtful developers coming along and like sincerely trying to do their best to like keep things working. You know, which I think most developers, that's what they want to do. So this is what it looks like, and you know, we integrated JS DOM so that you can run browser code at the console. It works great. You can see this is like a trivial test. It takes about under 0.2 of a second to run. I still wish it were faster, but we made some trade-offs that I'll describe now. So the test environment is written in Node.js, and that alone gives us like a lot of speed benefits. So you know, before we start, we actually kind of have to scan all the JavaScript files. It's really easy to do that in parallel in Node, so that's great. We also had to integrate JS DOM and Contextify in order to support browser code, and that slows us down. You know, and again, like I wish we didn't need Contextify. That I think was a mistake we made. For isolation, we did a couple things. One is we made it so that each test runs in its own VM, and that prevents cascading failures. Because I think like if developers get used to the idea that you know unit test breakage doesn't necessarily mean that something's broken, they'll start to ignore it, and then you know the tests rot really quickly. The other thing that we did is we made it so that by default you get a mock when you require something, and this was actually inspired by Felix Gusendorf, who's I think he's here. He presented at NodeConf like over a year ago his microtest framework, and you know it's the idea of using require as a theme to inject test doubles. And it's great. It works really well. That was pretty awesome. I'm looking for that guy. But you know, I can talk a little more about that, but I don't have a lot of time. OK, and then the last thing is you know, this hackability idea. And there, the best thing working for us is Node. So at Facebook, we don't have production systems that run Node, but there are a lot of people who do want to hack on Node. So the very fact that it's all written in Node is great. And then the other thing that we did is instead of integrating with crappy old legacy systems, we rewrote them. You know, even though it was extra work, it makes it so that like all the code is shiny and new. You know, when you go track down a dependency chain, like you're looking at JavaScript code and not crazy legacy PHP. OK, the last thing, and this is like kind of where it gets weird, so come with me. You know, we sort of abandoned like object-oriented programming for this, or at least like sort of the framework-style MVC. And I want to talk, yay! And I want to talk about you know why we did that. So here, we'll consider that chat tab view, that window. And you know, here's like a classic MVC constructor for that thing. We're going to take a thread object and a DOM node, and what we're going to do is like attach our template for the window to that DOM node. And like, let's just think about what we need to do to fill out the top bar of that chat window. That needs to say like, you know, Adam, Nan, and 2 others or whatever. So you know, when you start off and it's like a sunny day and you know it's the first file of your new project, you write something like this. You say, oh yeah, the thread has participants. So we'll just get those participants, and we'll like map over all the names of the participants and use that to generate the title. And you know, this works. This is great. Toy program. You like go show it to the product manager. He's all excited. You know, keep going. So, but then you realize that you know sometimes you get a message and you don't have the data for the thread. You need to be able to talk about this thread just as an ID before you really know what's in it. So cross that out and replace it with like some evented thing where you know the thread has a load event that distinguishes between the case where it's got data in it and it doesn't. And then you have to kind of wring your hands a little bit about like, okay, but what if it already loaded by the time I get here? What does that mean? But there are answers to that question. So now you sort of wait for this load event, you register your callback, and then you get the participants for that thread. And that works for a little while until you get to this group chat feature where you realize that like you may end up on a thread with participants who you don't know about yet. And what are we going to do about that? And this is where you see two approaches. One is people try to like have this invariant that we never have threads that don't have participants. At the best case, that leads to overfetching, right? Because like that means that every time you find out about a thread, you have to refetch all the participants. Worst case is like you have a bug or you've failed to capture this untracked dependency, and you get to the client and you're trying to do this, render a thread, you're missing participant data, and the only thing you can do is error. You've got no way out of that. So probably the best thing to do is to not do this and do the same thing to participants that we did to threads. So we wait for the load of the thread, and then we have to wait for all the participants to load, and then we can finally render the chat tab window. And by the time we get here, like this is no longer shiny and simple. It's like now really complicated, and you've got this sort of spaghetti evented system. You've got like subtle ordering dependencies, like if participants load before threads, that may kind of change the behavior here. It's not obvious what's going to happen. So there are two things that like I really don't like about this style. I'll try to point them out quickly. The first one is, let's just be okay with constructors and initializers and like class keyword, thank you. But we have two different kinds of APIs that don't look different, right? Like the thread knows its ID, and you can always call getID. That's fine. But to call getParticipants, you have to wait for the load event. And like, there's nothing obvious in the API that says this. You have to kind of like read through the code or keep the documentation up to date or whatever to really know this. And new developers will come along, and it works sometimes. So it's like really confusing. The other thing that really hurts is testability, right? So like, consider our test for the participants' behaviors around threads. What we're going to do is, we can make a new thread. That's easy. But when we call getParticipants in the context of a test, it's like unclear what we need to test here. Like we can do two things. One thing we can do is we can sort of return real participants from this call, in which case, like now we don't have a unit test. We've got an integration test of threads and participants. Or we can return mocked participants from here, in which case, like the mock for participants needs to be really clear about like what is done by participants code and what is done by thread code. So you've still bundled these things together, and pulling them apart again is pretty hard. And this makes me wonder, like, why do we do this whole object-oriented programming thing? Like, what got us here? And the first part, we're all programmers. The one thing I think we're all good with is abstraction, right? Like you wouldn't write code if you didn't like abstraction. And I think that's something we can keep. So in the chat code, there are definitely like function constructors and function prototypes. They tend to be for like UI controls, like that menu or the chat tab view, things that we're going to have a few of. But that's where I would say it stops. Like inheritance. That's one where like even in languages that are built around inheritance, like Java, like the best directive there is to use delegation rather than inheritance, because it's just so brittle. Like once you put something in an inheritance tree, then you can't get at it from anywhere else except subclasses. And no one really does a good job of like designing for inheritance. Like designing an API is hard, and then designing a class that can be inherited is like 10 times harder. Polymorphism is another one where like if you have a language that has first-class functions and callbacks, I just don't get why you'd have this crazy contract that says like, by naming this function show, I am participating in the showable interface, which is like, again, this like super untracked dependency in JavaScript. When a callback totally suffices there and is much more flexible. It means that you can have sort of pieces of code that aren't expressed as objects but can still connect to components that are. And then the last one, this is the worst one. I don't even get why this was a benefit in the first place. Like, data that is hidden is data that is not serializable. So like when the browser page unloads, when the machine crashes, when you migrate data, this is the stuff that you lose. And in Facebook chat, what we found is that like we had to externalize everything. We have to account for multiple clients, marking things as read or opening chat tabs or whatever it's going to be. So like all of our data ended up externalized, and we sort of now I think of like application data should always just be JSONable data. Like it should never be hidden in this way. OK, so that's my little rant. What did we replace it with? So I have to scare quote this because like we used a functional style, not strict functional at all. And there are places where we have objects, and it's intermixed. But like in general, I would say modules are connected by functions and not by events or named interfaces. Instead of like class instances, so instead of a thread instance, we use a singleton to represent like all the threads. And then this last thing is the thing I just talked about, where like application data is generally sort of thought of as always serializable. So let's go back and look at that chat tab view example now. And the first thing you'll see is that like the signature for this constructor is different. Instead of getting past a thread object, it gets past a thread ID, which is just a string. And now to go get the data about that thread, first we're going to attach a template. That doesn't change. We're going to pick out the title just so that we can close over that. It makes the code look better. But then when we want the data about that, we pass that ID back to the thread singleton and go and pass a continuation that will get handed the data about that thread once we have it. And that means that like if we have it, great, you get called back right away. If we don't, we can go back to the server and get it for you. So this continuation then gets the thread metadata, and we do the same trick with participants. And you'll notice that thread and participants are completely decoupled in this case. So this changes the API. It makes it simpler, right? Threads is just a singleton. And you can obviously tell like what things support direct return. So like, let's say there's some trivial ID transformation that we can do on the client. Obviously, you just pass in an ID, you get back the normalized ID. But the get function here takes a continuation. So you know that you have to pass that along with your call. For testability, it's like a similar thing where, instead of being bound to the participants' data, we can use like a mock function here. That we just made this like utility knife function that can be called as a constructor or an instance method or a raw function. It captures the calls and can also be used to inject return data. So here we just pass a mock function to this callback, and then we can poke it stuff, do various things with the mocks, make sure that threads made an async request if we expect it to, whatever that's going to be. And then when we want to verify the data, again, it can be expressed in JSON. So we just have like this simple equality check to be able to talk about our expectations there. I do want to at least build up a straw man and tear it down about this functional style. So what are some of the things that I hear objections to? I think the most common ones like, this is too hard. Like 4 layers of nested callbacks is like, it's too hard to follow the code. It's too hard to write the code. And people usually talk about this as like, I get it, but someone else wouldn't. I guess what I would say is like, yeah, coding's hard. That's just the way it goes, buddy. Writing these apps are like if they weren't hard to build, then everyone would build them, and we'd be out of a job. The other side of this is that it's like hard to follow. It's like kind of it can be like really, and this is related to the like super indenty thing. I guess what I would say is I think it's clearer than the tangle of events you get in a lot of OOP code, and so I like it better that way. Another thing you see is like there are too many includes in these files, and it's true. Like at the bottom of our dependency chains, like I was looking at chat tab view to prepare for this presentation, and at this point there are like 40 includes at the top of that file. I guess the thing I would say is like at least the dependencies are tracked and not untracked the way they are in that threads participants example. And then the last one is like this is legit. Like you end up using bind a lot when you use this style, and that can be really inefficient. Like if you bind at every call site, like every time you call a method on another module and pass a callback, if you bind every time, that uses memory. So you do have to watch out for that one. I had hoped I'd have time for questions, but I don't. You'll just have to find me, and I'd love to talk about functional and OOP or chat or anything else. But I guess here's what I have to say. Modularity, that's the big win. That's what you absolutely need to do. Unit testing goes right with it. I highly recommend it. And vive la functional revolution. Thank you.